day and welcome to my class on Surds. The second class on Surds in particular, rationalizing Surds and equality of Surds, is what we shall be doing in this video. So if you haven't watched the previous video, my first class on Surds, please check the link in the description. If you haven't subscribed to my channel, please do well to subscribe by clicking the subscription button and endeavor to turn on your notification bell so that you will get notified whenever I drop a new video or we go live. Okay? Please also feel free to join my community on YouTube by clicking the join button and following through on any level of membership. Thank you very much. That being said, let us begin this particular video. So I'm going to start with telling you that we shall be discussing two things in this video. Number one, we shall be rationalizing Surds. Okay, so we shall be rationalizing Surds, and two, we shall be discussing equality of Surds. So without much waste of time, what does it mean to rationalize a Surd? So let's start with that. Rationalizing Surds. Okay, so to rationalize a Surd, to rationalize a Surd that is in fractional form, having a denominator that is sodic, we only have to make the denominator rational. So when we say rationalize a Surd, please take note of the fact that the kind of Surd we are referring to is a Surd that appears in fractional form. Okay, for example, a Surd in this form: a over square root of b. So a over square root of b is a fraction that has a sodic denominator. The denominator is a Surd, and when we say rationalize this Surd, what we mean is make this denominator that is a Surd to become a rational number. Okay, another example of cases where you would have to rationalize is, for example, a case like this: a equals b plus square root of c. These are forms of Surds that need rationalizing because the denominators are sodic in nature. Okay, so I'm going to be taking you through certain examples of Surds that need rationalization. So let's see how that is done. To start with, to rationalize a Surd, please take note, is to rationalize a Surd that is in fractional form having a sodic denominator can be done by making the denominator rational. Okay, so having denominator that is sodic, we only have to make the denominator rational. Good. That being said, let's see how that is done. So let's consider this case of a Surd to be the first type. So I'm going to call this type 1. Type 1 Surds that require rationalization. Let's look at this one and call it type 2 Surds that require rationalization. So I'm going to be showing you how to get this done. Now, to start with type 1, if you have a Surd that appears in this form, that is a over the root of b, a over a sodic denominator, all you have to do for type 1 is to multiply the numerator and denominator by the Surd in the denominator. So look at it this way. So we have a over root b as a Surd that needs rationalization. Why does it need rationalization again? It is because the denominator is sodic. So all you have to do to rationalize this Surd is to multiply this numerator a and the denominator root b by root b. So use the Surd in the denominator of the original problem given to you to multiply the numerator and denominator, and that would mean a times root b would give you a root b, and root b times root b, of course, is b raised to power half times b raised to power half, and by indices that will give you b raised to power 1, and b raised to power 1 is the same as b. So this will now give you b. Now, why is this Surd rationalized in this form? In this form, this Surd is rationalized. Take note, for you to rationalize a Surd in fractional form having a denominator that is sodic in nature, all you have to do is to make the denominator rational. So once you make the denominator rational, it means that you have rationalized that Surd. So anytime you have a problem like this where you would have to rationalize this kind of Surd, then all you have to do is to multiply the numerator and denominator by the sodic denominator. Now, that is for type 1. I'm going to be taking you through some examples on problems for that case. Let's go to type 2. So what if you have a case like this: a over b root c. The rule changes slightly. All you have to do in this case is to multiply the numerator and denominator of this particular expression by the conjugate of the solid denominator. So remember, in my previous class I had taken you through conjugates of surds, and I told you to form the conjugate of a surd simply means to change the sign. And why is that so? The conjugate of a surd is that surd that will multiply the original surd to give you a rational number. So please check the link in the description to that video, and it will explain more about conjugates of a surd. Now, how do we rationalize this surd? All I have to do is write a over b plus root c and multiply the numerator a and the denominator b plus root c by the conjugate of the denominator b plus root c. What is the conjugate of the denominator b plus root c? It is b minus root c. Remember, conjugates are formed by changing the sign in the original surd. So once you multiply the numerator a and the denominator b plus root c by the conjugate b minus root c, all you would end up having will be a times the numerator there will be a times b minus root c in bracket all over. This now is b plus root c times b minus root c, and that is difference of two squares. This will give you b squared minus root c all squared. Okay, and the result you would have will be a in bracket b minus root c all over b squared minus root c squared will give you c, and this will be the result of rationalizing that surd. Now let us take examples. I'm going to take you through several examples to explain rationalization in detail. So let's go through some examples. So if I ask you as an example, if I ask you to rationalize the surd, a, rationalize the surd 4 over root 5, b, rationalize the surd 2 over root 3, c, or let's put 3 root 3 here, and c, rationalize this surd 7 over 2 root 5. What would you do? These problems are simple, you need not worry. Let's do it together. So to rationalize, take note, implies using the solid denominator to multiply the numerator and the denominator. So I'm going to start with saying 4 over root 5 times root 5 over root 5. That is the first step you take. The next step you take will be to use 4 to multiply root 5. That will give you 4 root 5. And use root 5 to multiply root 5. Root 5 multiplying root 5 will give you 5. And why is that so? Please take note. That is because root 5 times root 5 is the same thing as 5 raised to power half times 5 raised to power half. And 5 raised to power half times 5 raised to power half gives you 5 raised to power half plus half by the addition law of indices. Check my video on indices. And that will give you 5 raised to power half plus half is 1. And 5 raised to power 1 is 5. So anytime you are asked to multiply the root of a number by the root of that same number, it will give you the number under the root sign. So please take note of that so that we don't have to repeat ourselves. Now, the next one we have to solve is this. So this problem has been rationalized. And why is that so? The denominator is now a rational number. So let's do the second one. 3 root 3. So for you to rationalize this number, this particular surd, all you have to do is to multiply by the surdic component here in the denominator. So I'm going to use root 3. You don't need to use 3 root 3 to multiply both sides, okay? That's the numerator and the denominator. All you have to look at is using root 3, the surdic component in the denominator. So that will give you 2 times root 3 will give you 2 root 3, and root 3 root 3 times root 3 will give you 3, which is this, times root 3 times root 3 gives you 3, and that would mean your answer will be 2 root 3 all over 9. Okay, now if you had used 3 root 3 times 3 root 3, you will still end up having the same result. So there is no need using 3 root 3, just simply use the surdic component in the denominator. Okay, so that being said, let us go to the third problem for the first type of surds that need rationalization. So this one will be 7 over 2 root 5. For me to rationalize, all I need to take out is the surdic component in the denominator, which is root 5. And I'll use that to multiply the numerator and denominator, and that will give me 7 root 5 all over 2 times root 5 times root 5, which is root 5 times root 5 will give you 5. So your problem reduces to 7 root 5 all over 2 times 5, which is 10. And this solves this kind of problem. Now let us look at another example. Examples on the second type. Now, for an example on the second type, please consider a case like this. What if you are asked to find this? 4, that is to rationalize this surd 2 minus root 5. Okay, for a case like this, all you have to do, remember, this is the second type of surds that really need rationalization. Take note, why do they need rationalization? It is simply because the denominator is a sodic is in sodic form. So to rationalize means to make the denominator rational. So for us to make the denominator rational for a problem like this, all you have to do is to multiply the numerator and denominator by the conjugate of the denominator. So I'm going to say 2 minus root 5 times the conjugate of 2 minus root 5 will be 2 plus root 5 over 2 plus root 5. So that will give me 4 times 2 plus root 5 in the numerator, and by difference of 2 squared, this will be 2 squared minus root 5 all squared, and that will give you 4 times 2, when you open up the bracket, is 8. 4 times root 5 will be 4 root 5, and this will be all over 2 squared is 4, and root 5 squared is 5, okay, by what we had said earlier on. So this will give you 8 plus 4 root 5 all over minus 1, which is minus in bracket 8 plus 4 root 5, okay, and that simplifies this problem. Now, what if I gave you another problem of this nature? That is, I gave you a problem such as 2 over 3 root 3 plus 1. All you would have to do will be, again, to multiply by the conjugate of this sort. So the conjugate will be, in this case, 3 root 3 minus 1, since this is root 3 plus 1. And this will be 3 root 3 minus 1 also. Now, when you multiply, this will give you 2 in bracket 3 root 3 minus 1 all over the difference of 2 squared, that is 3 root 3 all squared minus 1 all squared. And that will give you 2 root 3, 2 times 3 root 3 will give you 6 root 3 minus 2 times 1 will give you minus 2 all over 3 root 3 squared is 3 squared, which is 9, times root 3 squared, which is 3, minus 1 squared, which is 1. And this will simplify to 6 root 3 minus 2 all over 9 times 3 is 27. 27 minus 1 will give you 26. And this solves the problem. So if you have a problem of this kind, please attack the problem from that angle. All you have to do is to multiply the numerator and denominator by the conjugate of the sodic denominator or the sodic component. Thank you very much. Let's now move over to the next thing I want to discuss, which is equality of surds. Equality of surds. So this is the second part of this particular video or this particular lecture, equality of surds. Now I'm going to be telling you what it means for two surds to be equal, and thereafter I'm going to tell you where to apply the knowledge of equality of surds when solving problems in surds. So let us see. So two surds, I'm going to say two surds A plus root B and B plus C plus root D are said to be equal if and only if, that is IFF, if and only if A is equal to C and root B is equal to root D, which of course implies that B is equal to D. So if this condition is met for two surds, A plus root B and C plus root D, then it means that the two surds are equal. So please take note of that. Now, the next thing I want to tell you in this video is this. Where do you need to apply the knowledge of equality of surds? I'm going to put it here as my remark. The knowledge of equality of surds can be used in obtaining the square root of surds. So maybe or before now you never knew that one can actually find the square root of a surd. Please take note. Yes, it can. You can actually find the square root of a surd. Now, for you to find the square root of a surd will require the knowledge of equality of surds. So the knowledge of equality of surds is not a waste. It is not useless. You can actually use this knowledge of equality of surds, that two surds are equal when the following conditions hold. You can actually use that knowledge in finding the square root of surds. How do we do that? Let's consider this problem. Now, let's consider this example. So come with me. Now, let's assume that an example is given to you to find the square root of a surd 7 plus 2 root 10. So if you are given this kind of problem to solve, to find the square root of 7 plus 2 root 10, what do? The solution is simple. All you have to do is to assume what the square root of this will be. So I'm going to start with saying let the square root of 7 plus 2 root 10, let the square root of 7 plus 2 root 10 look like this. The square root of A plus the square root of B. So you will make that assumption. Okay? So when you are given a surd whose square root is required, all you have to do is to make the assumption that the square root will be equal to the root of one number plus the root of another number. Whether you choose to do it otherwise, you will still get the same result. Please take note. So the first thing again, please take note, is to assume that the square root of this number you are asked to find is of this nature. So what do you do next? Now, if the square root of 7 plus 2 root 10 is assumed to be square root of A plus B, of course, mathematically, this is how to write that statement you've made in the previous line. That the square root of 7 plus root 2 root 10 is equal to this, implies that the square root of 7 plus 2 root 10 will be equal to square root of A plus B. So I'm going to say square both sides. So once you square both sides, what will happen? Once you square both sides, the next thing you would have will be taking the square of, if you take the square of 7 plus 2 root 10, it will mean taking the square of this other side. Now, once you get that done, the square of a square root is the number under the square root. So if you take the square root of 7 plus 2 root 10, it will give you 7 plus 2 root 10. Okay? Let's come to the other side. So for this other side, the square of root A plus root B would mean taking root A all squared plus 2 times root A times root B plus taking the square of root B. Now this is a simple way to just expand. Okay, you can visit my previous videos on binomial expansion, although I'm going to be having a lecture on binomial expansion very soon, and I'll be uploading that video, so please watch out for that video. Now this will give you the square root of A squared is A, plus the square root of A times root B will give you 2 root AB, plus the square root of B squared, the square of square root of B would root B will give you B. So this will be 7 plus 2 root 10. Now the next thing I'm going to do will be to arrange this expression on the right hand side in this manner. That is A plus B in one bracket and 2 root A B. And this will be 7 plus 2 root 10. I want this part to resemble this part. Okay, so that is the next step you take. Now once you get that done, you will now do a little bit of comparison. So I'm going to say comparing the left hand side to the right hand side. When you compare, it will develop two equations for you. So you will notice that if you compare the left hand side of this equation to the right hand side of this equation, you will see that 7 resembles A plus B. So I'm going to write A plus B equals 7, and I'm going to call this one equation 1. The next thing I'm going to do, you will notice that this part resembles this part. So I'm going to say 2 root A plus B equals 2 root 10. I'm going to call this equation 2. Okay? Now, you may not even want to call this equation 2 until you simplify it. So let's cancel this and simplify further to get a better equation 2. So I'm going to cancel 2 on both sides, and that will give me root AB equals root 10, which of course implies that if you square both sides, you end up having AB equals 10. Okay, so let's call this a better equation 2. Now, from we could solve by saying, starting with equation 2, if you start with equation 2, we can make A the subject of formula, and that would imply that A is equal to 10 over B. Okay? So if you make A the subject of formula in equation 2, it will make A to be equal to 10 over B. Now I would say substitute for A equals 10 over B in equation 1. Once you get that done, take this result, A equals 10 over B, and substitute for it in equation 1. It means that wherever you find A in equation 1, you'll be putting 10 over B. So I'm going to quickly do that. 10 over B plus B will be equal to 7. And if I multiply through by B, this would imply that B, using B to multiply this side will give you 10 plus B squared equals 7B. And if you write this properly to be a quadratic equation, it would imply that B squared minus 7b, when you bring this other way, plus 10 is equal to 0. So you now see that the problem reduces to solving a quadratic equation. So that will be the next step. The next step will now be to solve this quadratic equation. Let's solve the quadratic equation quickly. The quadratic equation b squared minus 7b plus 10 equals 0 can be solved as follows using the quadratic formula. So my root will be b, and that will be plus my coefficient of the linear term, which is minus 7. So this will be minus 7 plus or minus square root of my coefficient of the linear term, which is minus 7 squared minus 4 times the coefficient of b squared, which is 1, times the constant term, which is 10, all over 2 times the coefficient of the b squared, which is 1. And minus times minus 7 will give me 7. Okay? And that will give me plus or minus square root of 49, which is minus 7 squared minus 40 all over 2. And this will give you 7 plus or minus square root of 49 minus 40 will give you 9 all over 2. This will reduce to 7 plus root 9 over 2, or 7 minus root 9 over 2. And that will reduce further to 7 plus root 9, which is 3 all over 2, or 7 minus 3, the square root of 9 all over 2. This would end up giving you 7 plus 3, which is 10 divided by 2, will give you 5, or 7 minus 3, which is 4 divided by 2, will give you 2. So it means that b is equal to 5 or 2. Now, please take note that we had said earlier on that a is equal to b, 10 over b. So if b, when b is equal to 5, what is a? What is your a? Question mark. Now, a will be 10 over b, which will be 10 over what b is, 5, meaning that your a will be 2. And again, look at it again. When b is 2, according to the second part of the solution, when b is 2, what is a? A again will be 10 over what b is, which is 2, and that will give you 10 over 2, which is equal to 5. So when b is 5, a is 2. When b is 2, a is 5. What then is the square root? The square root, if you remember what we said earlier on, the square root was assumed to be root a plus root b. So now that we have gotten that square root, we will now say the square root, we say therefore the square root of 7 plus 2 root 10, which was assumed to be a, square root of a plus square root of b, will be equal to square root of what a is. You could choose any one. If you choose your a to be 2, then you can choose your b to be 5, and this will be the result. Thank you very much for watching this video. Please go over all I have taught you again, and I'll be meeting you in my next class on Surds. In my next class on Surds, we'll be taking equations in irrational forms, which will be my last subtopic in Surds, my third class on Surds, and thereafter we shall be solving as many questions as possible on Surds. Please feel free to ask many questions in the comment section. Drop a like on this video and share this video to your colleagues all around the globe. Subscribe to the channel, join my community by clicking the join button, and I'll be seeing you in my next class. Thank you very much. I remain Dr. John Effiong Hussein.